Hello everyone. Today our topic is about the LAN principle. When we talk the topic of the TCP/IP, I say that we have to focus on the main layer, like the data link layer, like the network layer, like the transport layer. So about the data link layer, we also can divide the network according to the coverage. So we will have the LAN and the WAN and so on. So about the LAN, we also call it local area network. And this one, the characteristic is the coverage is smaller, but the bandwidth is higher. So we often will deploy the LAN in the building or maybe in the campus network, like the school. So this topic, we will know what types of the LAN. And the typical protocol in the LAN is the Ethernet network. So how many types of the Ethernet? And in order to avoid the conflict, we often will use the technology of CSMA CD. What's the principle? And we often will use a cable to connect with the device, like the router, like the switch. And the typical cable is a twisted pair, and also maybe some fibers. Besides the wired LAN, now in our network, lots of people will use a wireless LAN. So the last part, we also will talk something about the WLAN. What's the typical protocol? What's the typical device? Something like this. If you are interested, let's discuss now.
Hello everyone. Before we talk about the detail of the LAN principle, let's have a review of the last video. Which of the following layers does the TCP/IP reference model include? And here are 7 options. The correct answer is A, D, and E. The main words of this question is TCP/IP reference model, right? And we have 4 layers. From the last one is network access layer. Then is the network layer, transport layer, and application layer. So the answer is A, D, and E. I think it's very easy for you. Then let's see the LAN principle. What means LAN and why we need the LAN? According to the size of the network coverage, we can divide the network to become LAN, MAN, and WAN. So what means LAN? LAN is local area network, and it covers a small area but has high bandwidth. For example, maybe your home network, your school network, and your office network. And about the LAN, the key point, we also have so many protocols in the LAN to build the network and to transfer the page from one node to another node. And the main protocol we use is Ethernet. So maybe someone already know what means Ethernet, right? And here we have to know Ethernet belongs to the LAN protocol. And about the Ethernet, we also have so many standard protocols like IEEE 802.11, IEEE 802.3, and so on. So let's see the detail. What's the relationship of the LAN and OSI reference model? About the OSI reference model, we have the physical layer, data link layer, and the network layer, right? Of course, about the upper, we also have transport layer and so on. And about the LAN, it's located on the data link layer. And we usually divide the protocol to become 2 sublayers. One we call is LLC and another one we call is MAC. Do you still remember what's the function of each layer? We have to provide the service for the upper layer. So, about the data link layer, about the LAN, we will use the LLC sublayer, logical link control layer, to provide the service for the upper layer. We call it network layer. Maybe you use IP, maybe you use IPX. And we also use the MAC sublayer to manage the devices, the link of the physical layer. Because about the physical layer, we can use different cable, right? Maybe it's a coaxial cable, maybe it's a twisted PA, and maybe it's a wireless cable. So different cable, maybe we use different format to encapsulate the packets to transfer the information out. But about the network layer, I don't care about what cable you use. I only want to know what's the IP address and what's the protocol number, something like this. So who will deal with this different protocol to provide the same information for the upper layer? This is a function of MAC sublayer. And we also have different protocol standard like the AO2.2, like AO2.3, 4, 5, and 11. And about the LAN, we deploy the network at the beginning. We will use a cable to connect with a terminal, and then we can transfer some file, right? At the beginning, let's see something about the early Ethernet. And about the early Ethernet, we have so many technologies. And we have different protocol like 10-base-5, 10-base-2, 10-base-T, something like this. And the protocol will decide what's the maximal length, what's the speed, and how to encapsulate to become the binary and then transfer the packets out. So at the early Ethernet, we use a protocol is 10-base-5, 10-base-2, and 10-base-T. And what's the function of the 10? What's the meaning of base? What's the meaning of the number? I will explain you the detail later. In this protocol, the typical one is the speed. At the beginning, the speed only 10 Mbps. And we will use three types of media. One is coaxial is the thicknet, and we also have the CNET. And these two different type coaxial. The different one is maximal length. About the first one, we can connect the distance. The maximal distance is 500 meters. But the second one will only have 200 meters. But if you use the third one, you use the UTP to connect with the terminal. The maximal length is 100 meters. This is a limitation of the cable. And we also will use this cable to connect with the terminal and then to build the topology. And about the early Ethernet, we only have two types of the topology. One is a bus, one is a star. And this topology we already explained in the first video, right? Let's see the topology. The first one, we can use the cable of 10-base-5 and 10-base-2 to indicate to connect with the bus type. And we also can use the 10-base-T and use a device like a hub to build the star topology. So about the early Ethernet, the topology is very easy. And we use the cable and the devices also is very easy. Because we have to transfer the signal from one node to another node. And we have to use the cable and the device to connect with each other. Pay attention. About the Ethernet, we see we have different character, right? Like the 10-base-2, what's the meaning? The 10 means the LAN speed. Maybe at the early, the speed only 10, but now we already can see 100 Mbps, 1 GB, also 100 GB. But the meaning is same. The first characteristic is speed. And the second one, base means baseband. And another one is broadband. This is the second one. And the third one will indicate length. And if this one is a number, the maximal length is a number and multiply the 100 meters. That's why we say about this protocol, The longest distance is 200 meters. In ZNSC, the typical device is a hub. Pay attention about the hub. We can use a hub to connect with many hosts, right? Because about the hub, we can provide multiple physical ports. And this topology is very similar like the star topology. Do you still remember the star topology? All the devices connect with a middle device, and this topology we call it star. But pay attention about this one. About the physical topology, we call it the star topology. But about the principle, the internal principle, still the bus. The characteristic of the bus topology is at the same time, only one device can send out the message, and the rest of the terminal only can receive, cannot send out, otherwise there is a collision. So, about the hub in the terminal, there still is a bus topology. So the first one send out the message, then all the rest can receive this information. That means in this scenario, it's very easy to make a collision. If there is a collision, the message cannot send out successfully. So we also need some solution to reduce the collision. One is you only maybe connect less terminal. If you only have one terminal, it's very easy. You can send out the message anywhere, anytime. But if you have 10 or 100, maybe there will be a big collision. And another one, maybe we have to use some mechanism to reduce the collision happened. In this mechanism, we call it CSMA CD, Carrier Sense Multiple Access Collision Detect. So what's the principle of this mechanism? How to reduce the collision happened? Let's see the process. The first one we call is carrier sense. If 4 hosts connect with the same bus, at this time, if the host B sends a message out, and then host A and host C also want to send the message out, so they have to listen. To listen in the process, anyone sends the message now or not. Because now host B sends the message, so A and C also will receive the message from host B, also includes the host D, right? Because they are in the same bus. That means A and C cannot send the message out until host B sends the message successfully. So they will wait host B send out all the message. Then host A and host C will find. Now the path is empty. That means I also can send the message out. Who can send the message at first? Both of them. So A and C will send out the message maybe at the same time, maybe A is faster and C is later. So in this scenario, there is a collision, right? Because A sends the message out, the C also will send the message out. They use the same path. And if the collision happened, the message is a broken message. So the next step is collision detect. If the collision happened, then everyone cannot send the message again, and then to wait. When we can do the send message again, according to the backoff algorithm, that means if the collision happened, then they will have a time. This time to wait, and the time is random. Maybe, for example, A should wait to 3 seconds, B is 5 seconds, C is 1 second, and 5 is 5 seconds. So, in this time, all of the computers cannot send the message out until 1 second later. Then the host C can send the message out. After C sent out successfully, the next one is host A. So we will use the CSMA CD to reduce the collision happened. This is a mechanism. And another one, in this message, in this process, or the terminal or maybe the hub sends the passage out, or the packets needed to do the encapsulation successfully. So about the Ethernet, the main characteristic is the MIC address. So this one is very important about the MIC address. And about the terminal or maybe the network device like the router, like the switch, we have two typical important address. One we call is IP address, and another one we call is MIC address. So about the IP address, we usually say the format is the decimal like 10.1.1.3. And this IP address will be added into the RAM. And usually the operating system will use this IP address and we can send out some message. And why we use this format and how to calculate, about this one we will explain the detail in the next video. Now we will focus on the next IP address. This one we call is MIC address. And usually we will use the high decimal MIC address to indicate this address. For example, the MIC address long is 48 bits long in the binary number. Binary number means 010101 like this. And we usually use the 12 bits long hexadecimal number to indicate the MIC address. So usually we will see the MIC address like this, 00E0FC, something like this. And this MIC address will be divided into two parts. And the first one is 24 bits long, we call it OUI, organization address. And another one is 24 bits long of the AUI. Pay attention. If this MIC address created by the same vendor, the first 20 bits will be same. And how to distinguish different devices? We will use the last 24 bits long of the AUI. So this is a MIC address. And the MIC address usually will be added into the ROM. And we will see the MIC address in the network interface card. And generally, the MIC address cannot be changed. And IP address, we can use a command or some GUI page to change the IP address. So pay attention about the MIC address characteristic usually cannot be changed. And if the devices creates a MIC address, and the MIC address will be used all the time. And different devices, the MIC address should be different, should be unique. Pay attention about this one. And according different MIC address, we can divide the frame to become unicast and broadcast. And what means unicast? What means broadcast? Pay attention about this one. If there are 3 terminals, and every terminal we will have the different MIC address, right? And this MIC address we call is unicast MIC address. And the broadcast is special, means all the value to become F. That means if we use a binary format, all the value will become 1. So this is a broadcast. Why we have to distinguish the unicast or the broadcast message? That's because when the terminal receives different frame, we will have different action. The first one is if the receiving address includes a MIC address. This MIC address is the owner MIC address. Or maybe the address is a broadcast address. Or maybe it's multi-group address. And then this terminal belongs to the group. About this address, if I receive the message, I will receive it. And then I will deal with means de-encapsulation and to the next step. And another one, if I receive the message, not match this address, I will directly discard. If this address belongs to the address, maybe it's the owner MAC address, maybe it's the broadcast address, I will receive and decapsulate it and then send this message to the up layer. Up layer means your network layer, right? Maybe your IP protocol also will do the next step. So this is a different action of the terminal. So let's see the example. For example, if the left device sends out the message, of course we have to do the encapsulation, right? To add the source MAC address, add the destination MAC address, to tell all the devices where the packets will be sent and where we want to, who can receive this message, something like this. And about this destination MAC address is the Unicast MAC address, right? Because the MAC address is special one for the last BBB. In the bus station, in the bus type, when I send the message out, all the terminal can receive this message, includes the host of BBB and the host of CCC. But they have different action. The first one, I will receive it because the destination MAC address is my MAC address. But about another one, another terminal, I will discard, right? Because this MAC address not match the receiving address. So this is the first one. And the second one, if the terminal send out the broadcast packet, that means the destination MAC address is FFF. Then this message also will be sent out of all the devices. Then the action is receive it and deal with it. So this is a different action of the terminal. Okay, so this is the MAC address is very important. And another one, we will use the device to expansion the length of the network in the early Ethernet. And one, we will use the repeater. And another one, we can use a hub. Pay attention. If we expand the protocol is 10 base 5 or 10 base 2 network, we will use the repeaters to do the expansion. But if we use the UTP to connect with the device, we only can use a hub to increase the expansion, to increase the range. So this is a little different. But pay attention. Not only about the repeater, but also about the hub. All of them belong to the same collision domain. That means in the same time, only one device can send the message out. If two devices send the message at the same time, there is a collision, and the message cannot be sent out. So this is early Ethernet. Of course, maybe in your network, you don't use this cable, you don't use these devices, right? You don't use the hub. But it's better for us to understand about the faster Ethernet, or we call it modern Ethernet. So what's the difference of the faster Ethernet and what's the new cable we will use? Let's see the next video.